Good afternoon, and welcome to today's Energy Safety Canada webinar, Controls Are Complicated, with our presenter, Dr. Andy Reimer, and I am your host, Andrew Davis. Just before we get started, do please interact with us. Andy's looking forward to your questions and input. You can do that by clicking on the chat button on the bottom of your screen, and that will pop up a message box. You can direct messages either to the entire room or to myself if you're feeling shy, and I'll coordinate and put those in front of Andy. Alternately, if you are joining us from a mobile device today, you have that same functionality. You can click on the three ellipses on the bottom right hand of your screen, and that will pop up that chat option as well. Further, you can give us feedback or answer any simple yes or no questions that might pop up during the presentation. If you click on that participants icon, that will pop up a list of participants, and at the bottom you can see the response options there, yes or no, go faster or raise your hand. Alternately, if you're joining us from a mobile device today, you do have that same functionality as I've shown there. Just tap on that participants button. We're going to do a test of the system and just make sure everybody can both see our presentation and hear me clearly today. If not, myself or my co-host Adria will reach out to you and do some troubleshooting while our presenter gets started. So can you please click yes or no if you can see and hear this presentation? There we go. A couple rolling in. Alan, thank you so much. Or again, reach out via the chat if you're having any particular issue. All right, moving on. Today, we are happy to have with us Dr. Andy Reimer. Andy is the project safety system supervisor at Enbridge. He did formerly work with Energy Safety Canada in the Inform incarnation, where he worked with the regulators, industry partners, developing IRPs, guidelines, and of course, supporting the CORE program, which we know a little bit about. We've got a similar background, Mr. Reimer and I. So happy to have you here, Andy, and I'll let you take it away.
All right. I think am I successfully off mute, sir?
You are unmuted. Just need you to share your screen.
I will. I'm getting there. All right. There we go. I'll just give it a second. Are we seeing?
Yep, we've got your presentation. Perfect.
Fantastic. Thank you all for coming. Listen, I always appreciate somebody's giving up their lunch hour to do this. I'm worth. I mean, a lot of you are probably in home offices, and you've discovered that you can eat during meetings, as I have. But I appreciate the giving up of the lunch hour nonetheless. So thank you. Today's presentation I want to give you is called Controls Are Complicated, with the subtitle Get Over It, which has a certain amount of edge and by intent. And we're going to do come through the slides. You can ask questions as we go. I'm interruptible. Andrew may jump in if you've got something along the way, but certainly I want to leave some time at the end for kind of any questions. I always learn something if I get good questions in. So speaking entirely selfishly, I do want to leave some space for questions and allow you guys to get the question off your chest, to get clarity on something I might have said. Goodness knows, I'm bound to say something that that is misunderstood. So by all means, feel free to ask the question. All right. One moment. Is it working? Why is it not working? There we go. All right. I'm going to tell you a little story to get us started. And this is sort of the genesis of this whole project today. And that is, this would have been back, long time ago, but not that long ago. I'm seeing 2014 on the cover there. So around 2012, 2013 in that space, I was working for Inform at the time, now Energy Safety Canada, working with the subcommittee of the Drilling Completions Committee to rework IRP 14, which is on non-water-based drilling fluid. And the basic premise of this document was Um, it had been built, and then what happened was there was sort of an explosion with the shale boom. There was an explosion of drilling being completed with a hydrocarbon-based mud. And if you can imagine, if you know anything about drilling operations, a key piece of drilling operations is that as the bit bores down, you pump fluid down into the well bore, down through the drill stem. It comes out the bottom. The drilling fluid needs a certain amount of sort of just the right consistency, because it's designed to sort of lubricate where the head is crushing the rock, and then it's pumped back out, and it brings with it all the little bits of rock that's being crushed as you go down. So comes back out. Now, as the mud comes back out of the system, it ends up going over a device called a shale shaker that sits over top of a mud tank. I'll show you a picture of it in a second. And this, actually, I'll just go to it right now. There you go, just so you can picture it. So as the mud comes out with all the with the tailings and stuff, and it's got to shake out the solids, and the leftover fluid basically drops. And as you can see, the top of the tank is like a grating, and the liquids fall through, and it goes back into this circulation system. And you can see a little diagram we had around the circulation system. So that's the technology for you. What you need to know is that when drilling fluid or drilling mud goes from a water base, where it's relatively safe, to based on hydrocarbons, which were necessary for shale formation, so they didn't bloat. You just need it for a certain type of rock. Of course, now you've got a whole variety of health and safety risks that you didn't have before. Namely, that hydrocarbons, especially when you run them over a shaker like that, do two things. One is they create hydrocarbon vapors, and number two, they create a variety of oil mist, hydrocarbon mists, so little droplets in the air, which are not great when you breathe them in. There's a whole bunch of issues. And the regulator in both British Columbia and Alberta was really on the industry's case to sort out the exposure issues that were around these hydrocarbon-based drilling fluids. So here's our committee. We're all meeting together, and we've got really great people on this committee, and they've got all kinds of ideas about how we can solve this hotspot, because as you can imagine, the shale shaker is a real hotspot, because you're agitating the fluid, and on top of that, you're sitting, on top of this tank. And we're thinking, how can we solve this problem with a clever control, and particularly in engineering control? And I remember at one point, I think one of our contracted, like an oil field equipment rental company, was being really innovative, and they had experimented by putting kind of like the equivalent of a giant sort of ventilation system on top of a big platform on top with a big powerful fan. And the idea is it would just suck up all as the mist and vapors coming up off the top of the shale shaker, it would just boom, get it out of the area. And great system, right? Unfortunately, or fortunately, we'll decide later on which it is. We ended up with one guy on our committee by the name of Robert Waterhouse. And Robert Waterhouse was working at Encana at the time. It did not matter what crazy good out of the box, in the box kind of solution we had for kind of the management of hydrocarbon vapors and oil mist. You could not come up with a solution where Robert wouldn't kind of lean back and go, yeah, but that's a good idea, maybe, but here's all the problems. Now you've got this problem. Now you've got that problem. Now you got the other, like that cover, that would pull all the vapors up. He goes, oh, okay. He goes, great idea. He said, have you considered the following? Have you considered that by creating a vacuum on top of it, you may actually be drawing more hydrocarbons out from the tank beneath it, because it works as a graded tank, and maybe you've got more exposures than you did before. And he says, the other thing you haven't probably thought about is, as it comes out of the top of that, and now you're going to vent it somewhere else. Okay, so you're going to put a filter on to get the mist out, but now you've got hydrocarbon vapors in a place where people don't expect it, at least on top of the fluid tank. They know it's there, we can mask up, but now it's venting. Now you've got, you have fire explosion hazards, you've got exposure issues, and you've just moved it somewhere else and somebody won't expect it. It didn't matter what solution you came up with. Robert was capable of poking holes in it and showing why your solution didn't actually solve the problem. And that taught me, it was a wonderful, wonderful gift, because it taught me that controls are complicated. All right, another story to set the scene. 2019, when we were last allowed out of our homes, I ended up doing this presentation called Engineering Controls, They're Only Human After All. I did it at Petroleum Safety Conference in Banff, and then later on I did it in the fall in Winnipeg at the CSSC Professional Development Conference. And I'm referencing both because you'll know why in a moment in the story. So the whole premise of this particular presentation was that engineering controls are, of course, hierarchy of controls we'll talk about later in the presentation. Hierarchy of controls. Engineering controls are supposed to be sort of get rid of the human element. In other words, administrative controls, PPE, these other kinds of controls have all these human factors. But an engineering control kind of works automatically. It's kind of magical. You build it, you set it, you forget it, and it will just, it will engage, it will do what it needs to do without the human intervention, which of course isn't true. I mean, that's part of why they're complicated. We'll talk about that later. But anyway, so back to my point on this slide, I had a little activity on the front end of my presentation. And in both cases, I'm working with safety professionals. So my assumption is that everybody understands engineering controls. So I ran an exercise right at the front of my thing. I said, okay, give me an example of an engineering control. So I got everyone kind of broke up. Within your group, think about an engineering control and then talk about all the human factors that could potentially come to bear in that engineering control. So now, having everyone done group work, now you bring everybody back, you go, all right, okay, somebody, some group volunteer. And it was really painful the first time because the first 3 suggestions I got were not actually engineering controls. They were engineered devices, often alarm systems, and a number of other things, but not actually engineering controls. And if you've ever had to pivot on stage, because you never ever want your audience to feel belittled. You don't want to, you got. So managing this turned out to be really tricky. And I thought, okay, that's okay. I've got a second shot at it. I'm sure it was my explanation was inadequate. There was something with, I obviously, I hadn't been careful enough to explain this. We'll do better. Second time around, I'm going to do this presentation. It'll go better. So I go to Winnipeg, same presentation. This time it's going to work. We got a room full of safety professionals. Engineering control should be well understood in this room. Set it up way more carefully, way more explanation. What's an engineering control? Go back to the group. Okay, somebody give me an example. First thing I got was an alarm on a door. And I'm like, all right. So clearly it's not, there is something tricky about this stuff that I was not giving enough credit to how tricky it is. And I'm really appreciative for all the people who just spoke up and said, oh, I think this is an engineering control, because it taught me that this stuff is more complicated than I was anticipating. And I suspect that's true across the board. So let's back up the bus a bit. So to set this whole thing up, let's ask the more important question: why controls matter? So what I've got here is your classic health and safety management system. And I grabbed the core, the Enform core one. I even threw some Energy Safety Canada, some Energy Safety Canada colors on there. This is and every HSMS is some variation on this. Integrated management system, they have these elements: management, hazard assessment, hazard control, inspections, qualification, training, competency, emergency response, incident reporting, investigation, system administration. This is classic management system stuff. All right. Now, here's when we work on safety inside small and large companies and work on safety systems, we think about this as this multi-headed beast. But this is an important sort of principle that I came to understand and really embrace during my time at Energy Safety Canada, as we worked through a variety of projects, and it turned out to be true again and again and again. And that is really, we need to kind of rethink our picture, and rather than sort of a management system that has all these equal parts, in fact, when you're dealing with safety, at the core of all safety is hazard identification assessment and hazard control. Everything else, all your other elements, that's really at the core. All your other elements are actually come out of that, support that, drive that, but that's actually the core piece with an E, but it should also be the core piece in the other sense. Anyway, I digress. And within that nexus of hazard identification, assessment, and control, the most important piece is control. Why do controls matter? Because there's only one element in your entire health and safety management system that actually prevents your unwanted event, that actually prevents the incident, and that is hazard control. So this has to be at the center of this whole system. All kinds of elements, all kinds of things, but at the end of the day, the difference between somebody getting killed, somebody getting injured, a pipeline opening up, a well losing control, the difference is, did the controls work or did they not? This is the stuff that actually prevents it, okay? Right. Just assume we're all agreed on that. So, great. Very simple. Controls are what matters, but they're complicated. And why are they complicated? So, let me count the ways. All right. This is going to be in the category of the "Are we done yet" syndrome. So this is for those who've got kids, and who have staff, with attention spans accordingly. So almost inevitably, when you get to that core piece of hazard identification, assessment, and control, and we're going to do it a variety of different ways depending on what kind of safety you're into, the nature of the work of your company, so on and so forth. But you're always going to have sort of this flow, and the flow always goes like this. You start with identification, then some kind of assessment, and then finally you do control. And I think a piece of the puzzle, a part of what I've noticed, is that we get really fixated with hazard identification. We put a lot of energy into that. And often, and I think part of that is because when on the incident side, right? Whenever we have an incident, how often do you put your finger on, they didn't notice that hazard. They didn't spot the hazard. So then we keep coming back with, oh, our hazard identification isn't good enough. They didn't notice the hazard. They didn't notice the hazard. So we keep pouring this energy into hazard identification. And by the time we get to hazard control, it's late in the session, it's late in the day, it's late in the process. And the energy we had for hazard identification is lost by the time we get to hazard control. This is just a classic human factor, right? And if you think about sort of the simplest version of this, if you're doing those classic job hazard assessments, JSA, whatever acronym you use for this little diagram I have here, and then there's many. But when you break the job into steps, I guarantee almost everybody who does this, what they'll do is they'll break the job into steps, then they'll go back and you'll argue a bit about where the steps go, and then you'll add the hazards. And what gets done last? Always the controls. The controls always get done last. And by then you are keen to get started on work. By then you're keen to wrap up and get on, or if you're doing a bunch of these, you get on to the next one. You know, all the discussion, brainstorming around the hazards has petered out by the time you get to controls. And then and then we make it worse. When our formalized one now is starting to look increasingly like this. So now you've got the steps, you've got the hazards. We'll do a risk rating before we apply the controls. Then we'll think of the controls. Then we'll do a risk rating after the controls. Again, we're introducing more activities. And in many ways, this is right. There's nothing wrong with this, but I'm just saying, in the end, how much energy is left for really thinking through the controls? Often, so this is in the bucket of "Are we done yet?" syndrome. We work on controls when we're all asking the question, "Are we done yet?" All right, the next issue, the hierarchy of controls. So, given my last experience with this, allow me for a moment just to explain this briefly. Okay, so that every regulator, every health and safety textbook will tell you that once you have identified your hazards, you've assessed your hazards, you ranked your hazards, whatever language you're going to use, you then start to think about the controls you apply against your hazard. And thou shalt use the hierarchy of controls as a way of determining your most effective controls. And so you go from top to bottom. So your most effective controls, of course, is eliminate the hazard. Best control ever, for sure. Substitution, that one usually, it applies a number of places, typically with a chemical hazard. That's your classic example. You have a really toxic chemical that you're using in some kind of process. Hey, if we substituted that for something less toxic, we haven't totally eliminated the hazard, but by substitution, we've made it not as severe. So we've eliminated at least the delta between the two. Great, get that. Engineering control, the one that nobody seems to get. That's totally unfair. But an engineering control is fundamentally controlling, a number of ways to think about it. You're controlling at source. You're basically ensuring that the hazard exposure never hits the human interface. So this, at its simplest form, a guard over a moving piece of equipment is the simplest form of engineering control. More complex engineering control, a well blowout preventer, right? Where a variety of these kinds of devices we have that fundamentally prevent the hazard from hitting the human interface, from hitting human exposure. Administrative controls are things that involve, things that involve paperwork typically. So administrative controls can be everything from training to workplace rules, signage that declares workplace rules, don't go in here. If you tape off an area and say don't go in there, that's an administrative control. What else falls under administrative controls? Signage, training procedures. Work schedules. So let's say you have an exposure that you don't want. You want to limit the time people are exposed to that. So a chemical or a noise or something like that. Working your shift changes, rejigging shifts. So you're only 8 hours instead of 12, or 4 days a week instead of 5 or whatever. Those are all administrative. And then your last sort of line of defense here is PPE. And we're all used to that. PPE is the last thing you consider. Why? Well, it's because then the exposure is already full force coming at you, and all you've got left is kind of what you're wearing to protect you from whatever it is the hazard is. So PPE, of course, would be everything from high-tech PPE like SCBA to hard hats, FR coveralls, and gloves, the classic stuff, the safety glasses. And the idea is you work your way down here. And I remember we had a fantastic moment in one of the seminars we had back working IRP 14 when the regulator was out talking to industry about oil, oil-based muds, where the regulator is harping on the personnel on the drill floor getting exposed, hydrocarbons. And one in frustration, one of the drillers basically said, so you want everybody in rain suits and you want everybody, completely in rain suits and a mask. And the regulator fired back, no, that's just PPE. And that's the lowest form of the hierarchy of controls. We want other kinds of controls, which is great, right? That actually is the right answer. As we discovered with IRP 14, work your way up, right? We had all kinds of solutions, and turns out those are kind of tricky, which is, by the way, why you end up at PPE often. Okay, so the hierarchy of controls, as per my earlier story, turns out to be, it's deceptively simple. It's actually not as obvious when you actually start working with it in a practical way. And so why are controls complicated? I think the hierarchy of controls hides a secret. And the secret it's hiding, that some of you may know, but not everybody fully appreciates, is that as you move from the bottom to the top, so if it's effective top down, cost, complexity, unforeseen consequences move upward. And that has a lot of sort of interesting and problematic implications. We're going to talk about some of those. I think some of those you've probably already appreciated. Some of those, are from my earlier story. But this is part of the challenge. You can have, the regulator can tell you to go down, but your cost complexity goes the other way. All right, let's go next slide. All right, let's look at sort of some of these features. Engineering, and I have a whole presentation on this. I don't want to spend a lot of time on this, but just to remind you that with engineering controls, we believe that with an engineering control, we're going to remove the human element. It's a set it and forget it, right? Think about a classic example of an engineering control, mitigative engineering control, automated sprinkler. That's a simple form of it, right? The moment there's a sufficient heat or whatever kind of other detection method, it automatically opens up, doses something with water, right? It's fantastic. There's no human element. Except, of course, there is, right? Why do sprinkler systems fail? Oh, we forgot to do maintenance. An installation, everything got piped in, but the last connection to the water source never actually got connected, right? There's all these ways, there's all these human factors in the design, building, maintenance of engineering controls where things go horribly wrong. And that's typically how engineering solutions fail. PPE, how can PPE go wrong? Unintended consequences. This is a classic example. I won't give you a work example. I'll give you a hockey example. One of the complaints that happened when back in the dark ages, they used to play hockey without helmets and without visors, is that everybody tended to keep their stick below their shoulder. The moment we put on helmets and visors, sticks got up. Why? Because there's a sense of invulnerability. The moment you give people more PPE, they will start to engage in unsafe behaviors because they have a sense of invulnerability that comes from the PPE. And so I have heard stories of people issuing brand new and improved gloves and having hand injuries go up, right? Because they felt invulnerable. The gloves actually didn't make them, but they felt that way. Completely unintended consequences. I guarantee the history of controls is littered with unintended consequences like that. What's another example? Where do these go wrong? Unintended consequences. Okay. Both administrative and PPE controls. Often we're going to go, And again, remember that cost, complexity, unintended consequences. We kind of deal with that with PPE and administrative controls by having a blanket approach. And this kind of comes out of safety's inherent distrust of the workforce that kind of permeates certain safety department cultures. And I think we worry about company safety culture. I think there's like a whole industry we could create around safety department culture, because one of the things that occasionally marks safety department culture is an inherent suspicion that if you don't really hammer the rules home and you kind of don't go over the top, nobody will listen to you. There's a certain insecurity there. So one of the things we have a habit of doing inside safety departments is create these blanket approaches, because it's so much simpler. So we create a hard and fast rule. So I'm gonna give you a classic story. So there's a company that I will leave nameless that is very large, and they had a policy that on their work sites, thou shalt always wear these really fantastic high-tech heavy-duty leather gloves and hard hats. And that was the hard and fast rule. And this particular company decided that as an energy saving move, their particular retail outlets would all be converted to LED lighting. So they needed to bring in electric contractors. And so this is one in the category of an overheard conversation that I then went over and had an extended chat with the person. So that one of the electrical contractors on the site starts telling his buddy the story of how it went. Well, the story of how it went was they're electricians in a retail space, retail building, and they've got these heavy gloves and they've got these hard hats. So day one and day two of the job, they have to crawl into kind of crawl spaces to get a hold of wiring. So the first thing they do is you can't actually get in there with a big hard hat. So they take the hard hat off, they set it to one side, they lean into do their work. Safety inspector comes by, you're not wearing your hard hat, you're home for the day. So the first 2 days, they just keep losing people. But thou shalt wear a hard hat all the time on this work site. The next problem they encounter are these gloves. You can't actually do fine wiring, which is what they need to do, with these heavy duty gloves. And this becomes a week-long debacle of these gloves. And finally, they reach a compromise with said company that they will continue to wear these gloves, but they are allowed to cut the fingers off these gloves in order to do the wiring. So we can all multiply stories like that. And my safety contrarian came back with, yeah, but it might still be better to have a blanket approach like that. That may well be the case. All of this is case by case, and there's always an argument for the other side. But my point on this story is simply this: is on PPE and administrative controls, we tend to go over the top. We tend to try to make it work in every circumstance. And we end up in scenarios where we're being inefficient. We're actually being ineffective. And the other piece that I think safety departments need to have a discussion about, and it needs to be an in-house discussion, by the way, listen to others, but take this to be and that is, are we bringing safety into disrepute? And I do think it's a question we need to answer. You can all say, hey, what a great safety culture. They weren't going to compromise on hard hats and gloves. And you can see it that way. But talking to that electrical contractor is going, really, really? And I think there's something to be said for making safety rational. Sometimes people won't understand controls and you have to explain why they matter. But if the truth is your only answer is, well, that's the rule, and in these cases it would help, so just do it all the time, there's unintended consequences to that. One is losing your audience. If you want people who just follow blanket rules, whether they make sense or don't make sense, fire everybody after 6 months. Hire a new person, fire them in 6 months, because after 6 months, people will start to figure out whether, in fact, a given control is rational or not rational. And if you give them irrational controls, there's unintended consequences. So, because after and they will start sorting out when they apply or don't apply. But this is a you know a piece of the control puzzle. All right, enough about that one. Engineering controls. And again, this speaks to the problem earlier, human factor. But not just human factors, technological factors here. And that is we'll come up with a solution for one problem, and we're so fixated on that problem that we fail to appreciate that the new technology, the new approach has introduced new hazards that we didn't stop and consider. And this is the illustration I threw in for my last presentation. To me, it's so powerful and effective. So I'm giving it to you because you can steal this one and use it the next time you're talking about engineering controls or why they're tricky. And that's the Boeing 737. So the whole premise, and you should be familiar with the story from a couple of years back, in 2018, 2019, the story really broke. Boeing had this exceptionally successive 737-800, but they wanted to get into the fuel efficient, the fuel efficient commuter plane segment of business. So they took their 737 platform and they changed up and swapped in this much more fuel efficient engine of the MAX 8 that you see below. But the net result of that is, as you can imagine, airplanes are carefully balanced pieces of equipment. And the new engine sat slightly differently with a slightly different weight, and it threw the balance of the whole plane. It adjusted the balance of the whole plane. So now a couple of things happen when you throw off the adjustment of a plane's balance. One is it's going to fly differently. So now, here's your problem. So if it flies differently, is it a different plane? And do you have to retrain all your existing 737 pilots on this new 737? And they came up with a very, and understand costs. There's this fine cost margin in the profit margin in the whole airline manufacturing business. And one of the ways they could sell this, just like the competitors, is they could say, well, you can go straight from the 737-800 to the MAX 8 and not retrain, because we're going to create the maneuvering characteristics augmentation system. And what it will do is it will use a piece of software that will cause this new plane to look and feel and fly exactly like the old plane. And you don't have to retrain. And this is really clever. And one of the pieces of the MCAS system is that it had an angle of attack sensor, which is this feedback loop. So it can tell, is the nose pointed up or down? And of course, if you follow the story, what actually happened is that angle of attack sensor on the outside of the plane failed, and the pilots had to start fighting. So the software system, the pilot adjusts, and the software system says, "Oh no, you're still pointed too far down. We're going, or the opposite way. You're pointed too up, and if you get pointed too far up, you're going to stall. So excuse us, Mr. Pilot, we're just going to take over for a second and bring the nose down." So the pilot pulls back up, and the sensor goes, no, you're still too steep. We're going to put you down because we don't want you to stall. This is a fantastic safety feature that prevents people from stalling their airplane. Except, of course, if it's not working and it's sending the wrong signals to the software system. In which case, you're headed down, it thinks it's stalling, and it keeps pushing the nose down, and the pilot can't bring it up. Now, had they thought about this eventuality? Yeah, they had. Of course they had. They had two little switches there that you could use to turn off the MCAS and get back to fully manual control. And as you can imagine in that cockpit, and this being a small piece of a booklet training, that in that moment with this new and unfamiliar plane, the pilots that crashed their MAX 8s did not put two and two together. They did not flip those switches. So, classic example. This is a safety feature. The MCAS was a engineered control. Automatically prevents stalling, ensures experienced pilot stays experienced, the best of intents. Great, but they didn't have Robert Waterhouse in the room, and they should have, because they added complexity, and the combination of complexity and tight coupling is at the heart of what's called normal accident theory, and it's bad news. And I'm not going to sort of spend a lot of time at it, but just to say that wherever you're ending up with this combination of complex system, and one system bleeds into the next, and you can't see which system is doing what at any given point, it'll run tickety-boo. But the moment something goes wrong, your ability to unravel what has gone wrong will not move fast enough for the event unfolding. The event will unfold faster than you can figure it out. So that sounds all really complicated. Forget complicated, read the simple version, grab this book. It's called Meltdown: Why Our Systems Fail and What We Can Do About It. This is like the most readable introduction to normal accident theory you'll ever get. And the beauty of this book is, if you're in one of those companies where you have to do office safety off the side of field safety and it's not your favorite thing, use this book to really ramp up your office safety to another level. Grab your risk, the people that need to kind of understand risk management, hazard management inside your office. Get them reading this book as part of your office safety program. So there you go. There's the pitch. Normal accident theory. So wired control is complicated. Here's another quick feature I'll get to. If some are good, are more better. Right? Here's your classic. You guys know the bow tie. I want to explain, right? Threats, preventive, the controls that prevent the event, the loss event, the unwanted event, the far side of it, which is the mitigation controls, and then so you don't get to the consequences. Okay, you understand bow ties. Just assume it. Go learn them if you don't. They're wonderful things. Here's the challenge. When we build bow ties like this, the instinct is that the more controls you have, the better, right? If some are good, are more better. And as you can see here, I don't know what this is for, but this is a classic picture of one of these. One of the challenges, the more controls you have, the more complex the system is, the more the chances these are tightly coupled, the more chances you have unintended consequences. So more controls, more unintended consequences, more is not better, but we think it is. And everyone will feel better when you've got 5 controls instead of 1 or 2. All right, so my latest challenge around why controls are complicated. I'll be brief on this one. So we had a couple incidents. So we had a couple incidents where a helicopter takes off with a load. And if you know anything about long line operations with a helicopter, every so often a load won't fly. This is the nature, and it will start to swing. It will do things that create a hazard for the helicopter. And the pilot has a button they can push. And when they push the button, they drop the load. Prevents the helicopter from crashing. Okay. So we had 2 loads jettisoned. And this was an incident that just, broke the alarm bell. Oh my God, we have a crisis around long lining here. So some of us were sitting around and form a committee, fly people around, bring in all the contractors, right? The usual response to we have a crisis. And it was interesting because some of us were sitting around going, I don't know, is that really even an incident? I mean, they dropped the load away from the right of way in a non-populated area. The dropping a load is technically a mitigative control to prevent the consequence of the helicopter crashing. So is this an incident, or is this just a control functioning as it should? And we had another very recent example. pulling out a piece of equipment, and the weight of that equipment was rated to the crane we had for it. What they hadn't accounted for is they kind of changed their plan partway through. A couple of flanges on either side that were supposed to get unbolted. They said, forget that. They just cut the pipe either side. So now you've got the valve plus this extra flange weight, and it turned out it exceeded the maximum weight for the crane, right? So the crane starts to lift. The moment pressure applies, the crane shuts down. Why? Well, the crane has an automated system whereby at 80% capacity, it goes, nope, we're not lifting beyond that. So is this an incident or is it not an incident, right? If the control was activated and succeeded, and some of you are going, of course it wasn't, and some of you are going, of course it was. And whenever I've already discovered on this scenario, this is like those diagrams. No, those are not diagrams. Like an optical illusion. Like, is it a young woman or is it an old woman? Is it is it a vase or is it two faces looking at each other? You can only see one side of this at a time. So trust me, there's another side. What do we do with this complexity of controls? Have a good try, and then just get over it. We have to get over it. And we have to literally get over the complexity of the controls if they're going to be effective. We have to know about them. We have to address it. They're the elephant in the room, but we have to get over it, because remember, what's at the core? What's at the core of our safety systems is hazard controls. If we don't solve this problem, we've solved the rest of it. Is just, is lipstick on a pig. It's not helping. So I think my challenge to you today is think big picture. Where are there opportunities to reprioritize so our safety management system efforts look more like this? I'm not, I'm sure I'm just planting the seed. I'm going to throw some suggestions at the end, but I want you to think seriously about what if we start seeing hazard control as the most important thing we do, at the center of what we do, and everything just supports that. A couple of suggestions on some of the specifics. Are we done yet? How do we overcome that? Listen, there's sort of some simple ways we can do that. One of the, just a simple suggestion, if you're ever going through whatever simple or complex version of hazard identification assessment control, obviously if this is like the moment before you're doing the job, I've got suggestions there, but let's say you're sitting down and you're going to take some time with one of these or do another one of these. Break it up, right? Do your hazard identification, hazard assessment, take a long break, do it the next day. Whatever it takes, when you sit down to do hazard control, make it feel like you're starting with something. Come in with fresh energy, fresh eyes, not like bedraggled, tired of the process. This stuff deserves, fresh energy, fresh eyes. Figure out how to do that with your processes. I think that'll make all the difference in the world. And then this is my other suggestion: cost, complexity, and unforeseen circumstances, consequences coming out of your controls. So you've got two options here. Either hire or nurture a whip-smart contrarian to play the devil's advocate for your control discussions. If you need to name somebody to do this job, do it. I mean, devil's advocate is a classic safety culture move. Bake it into your control discussions. My answer to IRP 14 and wanting to wring Robert Waterhouse's neck for killing every good idea we had for engineering controls is that the moment he became a free agent, I was on the phone and I dragged him into Energy Safety Canada, because it is exactly the skill set we need to pull into our safety teams, is those who can poke at our solutions, poke at the solution, poke at it, and then learn patience. This is exactly who you need. A very closely related suggestion, that field safety person that you dread seeing, if they're a manager or a team lead, or just the really, the dominant person at a field site. And that whatever you do, they're going to say, oh, that won't work. And they drive you nuts. Now, there are people who just say they won't work and they're just being difficult, but sometimes you will find a real gem there. And you want to take that field person that you have labeled as difficult and as always against change, and you want a new title for them. You're going to call them your resident expert. And the next time they say, oh, it won't work, don't let them get away with it. You go, okay, pull out a pencil and paper and say, listen, I want you to describe to me why it won't work. Because even if in the end you push through with it, they will tell you all the ways you can improve it, all the unintended things you didn't see, all the ways it will go wrong. They may not be right, but they will force you to think of new questions. So contrarian, now known as resident expert. On controls, there's a series of sort of what I call counterintuitive principles when it comes to controls. And you're going to have to trust me on these. You're going to go away from this presentation, think about it, and you're going to understand why this matters. You want fewer controls. You want simpler controls. You want more visible controls. You want independent controls. You want cheaper controls. You want maintenance-free controls. When you create a diagram like this, don't count the controls, weigh them. How effective are they? How fail-safe are they? Really effective one that's really effective fail-safe, everybody knows about, everybody can see, everybody monitors, is far more valuable than 10 that only one person knows about, nobody else does, or it's high maintenance, or it's really expensive and won't get implemented till 2 years from now. Go back to these principles. These are not the principles you will normally think about doing controls. You need to. The other thing, stop managing incidents, start managing controls. You know that example I gave you with the helicopter and the crane? Forget about, is it an incident or is it not an incident? You have had, in that instance, you have a control that failed and a control that worked. Both of those are really interesting. And you're in the business of managing controls, not incidents. Why? Because right now, our incident rates are so low in the industry, it's bouncing along, it's static. And leadership will keep worrying if you're at 0.5 or 0.75 or at 1 and 1.25. Listen, within the context of the safety department, we know that's mostly static noise, and rarely do you get intelligence out of that. The intelligence you need is, are my controls working or are they not working? And you know what control performance measures are? They're leading indicators. It's one in the same bucket. You keep talking about leading indicators. All that is are you measuring that the controls you got out there working? That's leading indicators. So that's where you want to go. That's one way that you throw safety controls at the center of your system. And I think one of the things you want to think about and consider, especially if you've got major accident risk with your work, is consider, or at least take a look at critical control management as something you can embrace within your company, or some variation on it. These are the two documents, Energy Safety Canada, that very focused approach, really simple. We'll walk you through it. Fundamentally, this is just a way of going, we're not going to manage thousands of controls. We're going to find the critical ones. And the documents will walk you through what's a good way to find just your critical controls. And then when we've got our critical controls, we are going to monitor the heck out of these, right? We're going to make sure our controls are working. They're not producing unintended consequences, that when we expect them to perform, they will actually perform. And again, try to drive simplicity into the control. Try to drive really straightforward visibility, simplicity into your oversight, insight into your controls. I think there's no way to get over the complexity of controls than to just start wrestle them and wrestle them into submission. And that's my challenge for you guys today.
All right.
I did not
Thanks,
leave enough
Andy.
time. I apologize.
Yeah,
more
we do
time.
have a minute or two if anybody has
Yeah.
has a couple of questions, but I put the link up to that process safety page that we have. It does have the barrier focused approach, the rebranded Energy Safety Canada version. So
Yes, sorry,
I
I apologize if I had the old version.
Yeah, no worries. Just a couple of examples that occurred to me Andy, positive air shutoffs. There's two
Yeah.
kinds. There's the kind that the driver has to, flip the switch on, but there are those
Yes.
automated ones.
Yep.
We've seen those, and they are a engineering control, but they require maintenance. Otherwise, they carbon up, and when they go to
Yep.
engage, they stick. So, there's an example there.
Oh,
Yeah. Go ahead. Oh, I looks like I lost him. So we'll give him a second to rejoin. Another one that I thought of was, talking about your control of PPE coveralls. How often do those get replaced? I've seen many a hand with old, worn out coveralls. So, how effective are they in a flash fire? Perhaps not. So anyhow, we are drawing quickly close to our time here, and I do want to cover a couple of pieces before we sign off. So we are coming up to our summer break for webinars. We're going to be away here for a few weeks and get some vacation time in. But do please join us again in September. We have a few scheduled. We're going to be talking about due diligence with the BC Employer Appeals Office, having a mental health discussion with our friend Mitch Hermanson of the Movember Movement, and Patrick Delaney will be back with us and giving a presentation on harassment and violence. So please do look to those in the coming weeks. They should be announced in August for September. And as always, register at energysafetycanada.com/events. Finally, we will have a survey coming out today, so let us know what you thought of today's presentation. Do you have any direct feedback for Andy? And of course, what other presentations or webinars would you like to see from Energy Safety Canada? Let us know so we can meet that need and improve. With that, we're going to be signing off for today. I think Andy might be back
My
with us.
apologies, Andrew. I'm so sorry, man. My system just, it could have happened at a worse time, so I do apologize.
Yes, yeah, no worries. So it kicked out right at an opportune
at an appropriate time. Listen, if anybody, I'll just put it out there. I'm at andy.reimer@enbridge. If anyone has a specific discussion, I'm passionate about this. I am certainly happy to have a follow-up discussion with anybody on this.
Yeah, for sure. And any feedback that comes directly for Andy, I'll be sure to pass on through that survey link. But we are at the end of our time today. Andy, thank you so much. Very appreciative of your time and industry knowledge and sharing. And we'll have to have you back another time.
Thank you.
All right, everyone have a safe and successful day. Take care.